All right, so in the last video, we developed this equation for the required footing area using the net allowable soil bearing pressure when we took out the effect of the footing itself. So let's use that in this example. So we're going to size the spread footing for column B3 in the building shown below. So the footing thickness is going to be 1 foot 9 inches. We're going to assume that the footings bear on silty sand with an allowable soil bearing pressure of 3,000 pounds per square foot. So we'll treat that as a given. We don't have to refer back to the table. All right, so the load from the roof and the second floor framing is going to be transferred through the columns to the spread footings. So column B3 supports 2 girders and 2 beams from the second floor. It also supports 2 beams and 2 girders from the roof. So we're going to assume that an engineer previous to us has already performed analyses for the floor and roof members with the following results. We have the roof beam reaction as 5,000 pounds, the roof girder reaction as 10,000 pounds, the second floor beam reaction is 5,000 pounds, second floor girder reaction 27,000 pounds. Okay, we're going to take that all as given. So we have a column is going to typically carry the loads from the roof and those floors, as well as its own weight. And we got to add all of that up to get a total load here. So the footing will carry the column loads as well as the weight to the foundations and transfer these loads to the supporting soil. In this case, we have the roof loads include the 10,000 pounds from the 2 interior beams that frame into the column. We have 20,000 pounds from the girders that frame into the column. Now also the second floor, we had an interior beam end reaction, 2 of those, 13.5 gives us 27,000 pounds, and then 2 floor beams, from the girders, not the beams, the girders, for a total of 54,000 pounds. In addition to that, the column itself weighs 1,500 pounds. So all of that adds up to a whopping 112,500 pounds. Now the building loads will create a pressure on the support soil equal to the total force applied, but divided by the area of the footing. All right, so we have our total column load, 112,500 pounds. So now we need to calculate the net allowable soil bearing pressure. So first, we find the pressure caused by the weight of the 1 foot 9-inch thick footing. Now careful, that's not 1.9 feet, that's 1.75 feet, 1 foot 9 inches, times our density of concrete, 150 pounds per cubic foot, gives us 262.5 pounds per square foot. That's the pressure from that thickness of footing. So then we're going to subtract that footing pressure from the allowable soil bearing pressure that was given to us, 3,000 pounds per square foot. So now we have a net allowable pressure of 2737.5 pounds per square foot. That's the net pressure that we want to use. So the required footing area is our next step. We want to find the required footing area by calculating the column, using the calculated column load and Q net. So the footing area must be 112,500 divided by our 2,737.5 pounds per square foot, which is the Q net that we found. We get a whopping 41.1 square feet. We need at least that much area of footing to maintain the allowable soil bearing pressure. So once you know the required footing area, you got to decide on the shape of your footing. So many spread footings are square unless a specific reason exists to use another shape. Usually that's just easier to pour, easier to make a form in the shape of a square. So for instance, a spread footing that supports maybe 2 footings and may require a rectangular shape in order for it to fall under both footings. You could have an interference with some underground equipment that may now allow a use for square footings. In some cases, when the area is small, circular tube forms may be used to reduce construction costs, and you have a circular footing. So it depends on your application. So if we're going to calculate the square footing size, area of a square is the 2 sides squared, or x squared if x is on either side. So 41.1 square feet equals x squared. Take the square root of both sides. We get 6.4 feet. So now 6.4 feet is equivalent to 6 feet, 4.8 inches. Now always round up when designing footings. If you round down, the design soil bearing pressure is going to exceed the allowable soil bearing pressure. This was a minimum that we set. We always need to round up from that minimum. Designers are going to typically round up to the next 2 or 3 inch increment. So we're going to round this one to the next 3-inch increment. In this instance, say 6 feet 6 inches. All right, so if we're going to make a round footing size, similar, pi r squared is our area of that circle, 41.1 square feet. Goes pi r squared, divide by pi both sides, take the square root. We're going to get 3.6 feet. Let's say that's 3 foot 9 inches. And remember that diameter is going to be twice that, so a 7 foot 6 inch diameter circular footing. So that is finding footing.